Essentials of Data Transmission. Module 7. Angle Modulation. Angle modulation. Angle modulation results whenever the phase angle phi of a sine wave is varied with respect to time phi of t. Angle modulated wave can be expressed mathematically as shown in the slide. Angle modulation. Angle theta t is a function of a modulating signal phi m of t. The modulating signal can be expressed mathematically as shown in the slide. Frequency modulation FM. Varying the frequency of a constant amplitude carrier directly proportional to the amplitude of the modulating signal at a rate equal to the frequency of the modulating signal. Phase modulation. Varying the phase of a constant amplitude carrier directly proportional to the amplitude of the modulating signal at a rate equal to the frequency of the modulating signal. FM is indirect PM and PM is indirect FM, but both are forms of angle modulation. Angle modulation. Angle modulated wave can be seen in a slide. Instantaneous phase deviation theta of t radian. Instantaneous phase can be seen in a slide. Instantaneous frequency deviation can be seen in the slide. Instantaneous frequency can be seen in the slide. Phase modulation is an angle modulation in which the instantaneous phase deviation is proportional to the modulating signal. In frequency, the instantaneous frequency phase deviation is proportional to the modulating signal. This is a table of angle modulation. In this slide, you can see PM and FM sine wave signal. Phase modulation principles. Relationship between the modulating signal and carrier deviation. In FM and in PM, the frequency deviation is directly proportional to the amplitude of the modulating signal. In PM, the maximum output of leading or lagging phase shift occur at the peak amplitudes of the modulating signals. In PM, the carrier deviation is proportional to both the modulating frequency and the amplitude. Phase shift keying. The process of phase modulating a carrier with binary data is called phase shift keying or binary phase shift keying, BPSK. The PSK signal has a constant frequency, but the phase of the signal from some reference changes as the binary modulating signal occurs. This slide shows phase modulation of a carrier by binary data that produces PSK. Deviation. The amount of change in carrier frequency produced by the modulating signal is called frequency deviation, delta F. Meanwhile, the change in phase is called phase deviation, delta theta. The magnitude of the frequency and phase deviation is proportional to the amplitude of the modulating signal and the rate at which the changes are occurring is equal to the modulating signal frequency. Frequency modulation. The frequency of a carrier signal is varied in such a way that the instantaneous frequency deviation, which is the difference between the instantaneous frequency and the carrier frequency, is linearly related to the size of the modulating signal at a given instant of time. Spectrum. FM produces pairs of sidebands spaced from the carrier in multiples of the modulating frequency. Modulation index M of FM signal is the ratio of the frequency deviation to the modulating frequency. The modulation index determines the number of significant pairs of sidebands in FM signal. Bandwidth. Low index modulation or narrowband FM, bandwidth is equal to 2 times modulating frequency. High index modulation wideband frequency, bandwidth is equal 2 times delta FM. Actual bandwidth is equal to 2 times N FM. Use Bessel table where N is number of significant sidebands. According to Carser rule, bandwidth is equal to delta F plus FM. Delta F, peak frequency deviation, F, M, modulating frequency.